All right, welcome to day one. The new packet should be getting passed out to you. While that is being passed out, two things that you can be doing in your planners. You can be writing down day one for the homework, and you can also be taking your calculator out. So please be doing those two things right now. Our new unit begins with radicals. That's our topic for today. Radicals is a synonym for square roots. And once you have day one written in your planner, your calculator out, we'll start out on page one. So we want to simplify radicals. So first, just a brief overview of some basic radicals you've seen before. So square root of 25, you might know is 5. And the reason for that is 25 can be written as 5 times 5, or in other words, 5 squared. So a radical or a square root is undoing a squared. So if radical 5 times 5 is equal to just plain old 5, what we want to do is we can write out our number under the radical as multiplication, or in other words, factors, and any repeats would then come outside the radical. Now there's a nice thing on the calculator that does this for us. So our number under the radical is 108 in this first one. So let's everyone go to a calculator page on their calculator. And we're going to go to Menu, Number, and Factor. And we want to type in that 108 and hit Enter. Notice we're typing in 108 and not the square root of 108. And when we hit Enter, it gives us the prime factorization of 108. So what we're going to do is we're going to take that 2 squared times 3 cubed, and back on page 1, we're going to write that under our radical, but all multiplied out. So we're going to have 2 times 2 times 3 times 3 times 3, because that's the same as saying 2 squared times 3 cubed. And what we want to do is we want to look for pairs of the same number. So we've got a pair of 2's and we've got a pair of 3's. One of each of those pairs goes out front. So out front we're going to have a 2 times 3. So the 2 is because one of them from that pair of 2's, the 3, one of them from the pair of 3's, and then we have a leftover 3 under the radical because that didn't have a pair. Well, now just multiply the stuff out front. 2 times 3 is 6. So we get 6 square root of 3. And just to show you that those are equivalent, if we did square root of 108, and if we did 6 square root of 3, notice those decimal values are the same. And my calculator, I think, is on float 6, not on regular float, so it's not showing the decimals all the way out. So that's how we simplify a radical. We do menu, number, factor for the value underneath. And then we circle our pairs. One from each pair goes out front. And then any leftover things stay inside. So for the next one, 72, we'll go to the calculator. We're going to do menu, number, factor. And we get 72. So here we have 2 cubed times 3 squared. So we'll have 2 cubes, so we'll have 3 2's, times 3 squared, so we'll have 2 3's. We're going to circle our pairs. So 1 2 will go out front, 1 3 will go out front, and this time we have a 2 left inside the radical. 2 times 3 gives us 6. So we'll have 6 square root of 2. Now, if you have a number out in front of the radical, like we have a number 3, that just ends up going out front with any pairs ones that you had. So we're going to write this as 2 square root. We'll go to our calculator. We're going to do menu, number, factor, and we have 18. So we have 2 times 3 squared. So that's going to be 2 times 3 times 3. We've got a pair of 3's. So out front, this is the 2 that was already there. We have 1 from the pair of 3's and a 2 left inside. 2 times 3 is 6, so we get 6 square root of 2. So notice we have 3 different ways on this top of the page here to represent the same value. Square root of 72, 2 squared 18, and 6 square root of 2. Those all represent the same thing. All right, if we move to the bottom of the page, when you add and subtract radicals, they must have like radicands. That means the like numbers under the radical. So let's just compare that to algebra. If we have 3x plus 2x, that equals 5x. If we have 3x squared plus 2x, there's nothing we can combine there because they're not like terms. Well, it's the same thing with radicals. If I had 3 square root of 2 plus 2 square root of 2, just like with the x's, I add the numbers out front, so I get 5 square root of 2. But if I had, say, 2 square root of 3 plus 2 square root of 2, those are not like things under the radical, so you can't add those. So the one but about that is we're subtracting here. There's not like things under the radical. But we might be able to simplify them. So we want to see if square root of 90 will simplify. So we'll do our menu number factor for 90. We get 2 times 3 squared times 5. So this is going to be the square root of 2 times 3 times 3 times 5. We'll do our minus sign. And now let's do it for square root of 40. So we're going to go menu, number, factor. We'll put the 40 in. And we get 2 cubed times 5. So that's 2 times 2 times 2 times 5. We'll circle our pair of 3's in this first one. 1 goes out front, and we'll have 2 times 5 left inside. Minus. We've got a pair of 2's. One of them goes out front. We've got 2 times 5 left inside. The 2 times 5 gives us 10, so we'll have 3 square root of 10's minus 2 square root of 10's. Well, just like with x's, we're just adding and subtracting the number out front. So we're doing 3 minus 2, which gives us 1 square root of 10. But like x's, we often don't write the 1 in front of the x, so you could just write this as square root of 10. All right, and the next one, they're not like things under the radical, so we've got to see if we can simplify them. So take a moment, do your menu number factor for 3 and your menu number factor for 12. So for 3, we should have noticed it just came back as 3. And let's talk about why that is. What the calculator is really doing is it's giving us the prime factorization. So all those factors are prime numbers. That means those numbers have factors that are only 1 in themselves. So if you notice you have a prime number under your square root, you can skip doing menu number factor because that's not going to simplify it all. Now the 12 was 12 squared, or 2 squared times 3. So that one can be simplified. We're going to have 5 square root of 3 plus, we'll have 1, 2 out front with the 3 still inside. When we add those together, we're going to get 7 square root of 3. All right, moving to the next page, we'll do a couple more addition and subtraction examples. In number 6, notice we have 7 and 2 under the square roots. Well, 7 and 2 are both prime numbers, so they're not going to simplify at all. If you weren't sure of that, do menu number factor for them, and you'd see you'd get the same thing back. So we can combine these ones. They have the same thing under the square root. 11 minus 6 just gives us 5, so we'll have 5 square root of 7, plus the 3 square root of 2. Those square roots did not simplify, and they're not the same, so we can't do anything more. In 7, 2, 3, and 2, those are primes, so those ones aren't going to simplify. But square root of 4 will. You can either do a menu number factor for 4, or know that 4 is 2 times 2. So one of them is going to go out front, and then there's nothing left inside. So that's really just 10. Or you might know, because 4 is a perfect square, that the square root of 4 is just 2. Because 4 is coming from 2 times 2. Well, now our other parts, if we carry them down, we're looking for like terms to combine. Our only like terms are the square root of 2 ones. So we're going to have 10 plus 6 plus 7 gives us 13 square root of 2, and then we've got the minus 4 square root of 3. None of those are like terms, so we can't combine them. So up to this point in the lesson, we hope that you're comfortable simplifying a single square root down to simplest form, and also doing addition and subtraction by simplifying the square roots and then adding and subtracting any ones that have like things under the square root. So we're going to move on now to multiplication and division. Well, let's look at some example with algebraic things again to start out. If we had 2x times 3x squared, when we multiply those, we multiply the numbers out front, so we'd get 6, and then multiply the x and the x squared to get x cubed. If we divided, say we did 70x to the 5th over 10x to the 3rd. Well, we would divide the numbers and get 7, and we'd divide the x's, and we would get x squared, because 3 of the x's would divide out and 2 of them would remain. Well, multiplying and dividing with square roots is very similar to that. They don't have to be like terms, just like the 2x and the 3x squared were not, and you just multiply or divide the spots that are in the same location. So what I mean by that is, in this first example, 2 and 3 are both the numbers out in front of the square roots. So we would multiply those together to get 6. Then the 6 and the 3 are both under the square root. So we would multiply those to get what goes under the square root. So we've got 6 square root of 18. And then we always have to check and see if that simplifies. So see if you can go to your calculator, do a menu number factor for 18, and see if you can break down and simplify that radical expression on your own. So go ahead, try that now. So after our menu number factor, we should have had 2 times 3 squared. So that's 2 times 3 times 3. Circle the pair of 3's. One of the 3's goes out front with the 6. 2 stays inside. So this is 18 square root of 2. For division, when you have a fraction under a radical, you can write that as separate square roots. So these two things here are equivalent. But the first thing I would actually suggest is to always see if your fraction reduces. If you do 100 divided by 25, that actually just gives us 4. Well, now we've just got to work with square root of 4. If we did our menu number factor for 4, we'd get 2 times 2. So that's a pair of 2s, so 1 2 is going to go out front. Nothing's left inside, so we just get 2. If we move over to page 3 for number 10, we're dividing. So we can think of this as 18 over 6 times, and we can put this all under the same square root. We'll divide your things out front, divide your things in the radical. 18 divided by 6 is 3. 6 divided by 2 is 3. And then we've got to think about if this simplifies. You can either do menu number factor for the 3 that's under the square root, or 3 is a prime number, so we would know that it's not going to factor at all. So that's just our final answer, 3 square root of 3. Next, we want to do 4 square root of 2 squared. Well, squaring something is multiplying by itself. So let's write it out twice. We're going to multiply the front numbers. We'll multiply in the radical. So 4 times 4 gives us 16. 2 times 2 gives us square root of 4. Well, we just saw in a previous problem that square root of 4 eventually became 2 because it was 2 times 2. So this is really 16 times 2, which is equal to 32. Now, something that's going to play a role in our next few examples that I want to point out. Notice we did square root of 2 times square root of 2, which became square root of 4, which then eventually became 2. So really, square root of 2 times square root of 2 ended up in the long run equaling 2. Well, let's think about square root of 3 times square root of 3. That's square root of 9, which is square root of 3 times 3. So you have one pair, so the 3 would come out, so that's just 3. Well, let's say we had square root of 11 times square root of 11. Hopefully we can shortcut it now. If square root of 2 times square root of 2 is 2, and square root of 3 times square root of 3 is 3, square root of 11 times square root of 11 should just be 11. If we did square root of 112 times square root of 112, hopefully we're good shortcutting that now to know that that's 112. And the reason this happens, 9 is really 3 squared in this example here. And a square and a square root undo each other. That's why it just ends up as 3, what the original thing was. So that idea that a square root times itself is just the number underneath, we're now going to use in some examples. So many questions will ask you to rationalize the denominator of your fraction. We don't like to have a radical in our denominator. That is an irrational number. So rationalizing the denominator means making it something that's not a square root. Our technique to do that uses the principle we just saw, that a square root times itself should just equal the number underneath. So to get rid of this square root of 2 that's in the denominator, we're going to multiply numerator and denominator by square root of 2. The reason we can do that is if you multiply both numerator and denominator by something, it does not change the value of it because you're really multiplying by a fancy version of 1. Square root of 5 times square root of 2 will just give us square root of 10. Square root of 2 times square root of 2, we just saw above, is plain old 2. Well, this is great. We've got a rational denominator, which is what we wanted. We just have to see if that square root of 10 simplifies. If we did a menu number factor for it, we would find that 10 is just 5 times 2. There's no pairs, so that's the best that we can do. In 13, we've got that fraction. First, see if it reduces. It does not. So we can rewrite this as separate square roots. To rationalize the denominator, we'll multiply numerator and denominator by square root of 3, because that's really a fancy version of 1. Anything over itself is really 1. So this will give us square root of 21 over 3. So this is great. We've got a rational number in the denominator, which is what we want. We've got to see if square root of 21 factors. If we do a menu number factor for 21, we get 3 times 7. So there's no pairs there, meaning this is the best we can do in our simplification. So if we flip over to page 4, we've got a square root in our denominator. So we'll multiply top and bottom just by the square root, not the 2. Because the 2 is not a problem, just the square root of 5 is. On top, we'll now get square root of 40 over, this is going to be 2 times 5. Or in other words, we'll have square root of 40 over 10. Well, we now got to see if that square root of 40 will simplify. Take a moment to do menu number factor for 40. So we should get that this is really 2 times 2 times 2 times 5. So one of the 2's will go out front, leaving us with 2 times 5 inside, which is just 10. And then we have the 10 in the denominator. Well, we now have to see if this will simplify. You can't divide the 10 under the radical with the 10 in the denominator that's not under the radical, because they're not in like spots. But we can look at this 2 and 10. Think of it as 2 tenths. What does 2 tenths reduce it to? It reduces to 1/5. You don't have to write the 1 in front of the radical. If you did, it's not a problem, but we usually don't see it written that way. And then if we divide the 10 by 2, we get 5. Over to 15, 5/12 doesn't reduce, so let's write them as separate square roots. We can multiply numerator and denominator by square root of 12. This will give us square root of 60 over 12. Take a moment to do a menu number factor for 60. We should have gotten that 60 is 2 times 2 times 3 times 5. So there's a pair of 2's, meaning we'll put 1 2 out front. Inside is 3 times 5, which is 15. And it's over our 12. So the radical part's simplified as much as you can. Think of the numbers that are not under the radical. 2 12ths will reduce to 1/6. So we get 15 over 6. The last 2 on this page are just simplifying the radicals. These are kind of like the ones we did on page 1. And we're actually going to pause the video for 4 minutes to give you a chance to try these 2 on your own. If you need help, look back to the first 3 on page 1. But again, we'll pause the video for 4 minutes for you to try these. When you're done, compare your answer with someone nearby, and then after 4 minutes, we'll walk through how to do them. So go ahead and try those now. So for 16, when we do menu number factor for the 147, we should have got 3 times 7 times 7. There's a pair of 7s, so one of them goes out front. This 3 was the 3 that was already out front, and you have a 3 left inside. So we get 21 square root of 3. For the square root of 968, to your menu number factor, you should have got 2 times 2 times 2 times 11 times 11. You got a pair of 2's and a pair of 11's. That gives you 2 times 11 out front with a 2 still inside, or in other words, 22 square root of 2. So that's simplifying radicals, adding, subtracting radicals, multiplying, dividing radicals, and rationalizing denominators. Any time left in the period, you can start working on your homework. If you are stuck, look back at your notes. If you're still stuck, feel free to ask someone nearby. Have a great rest of your day.